Q6174. What causes wind? A. Coriolis force. B. Pressure differences. C. The rotation of the Earth. The correct answer is B. Wind is primarily caused by the uneven heating of the Earth's surface, which creates variations in air pressure. These pressure differences set the air in motion, resulting in the movement of air masses and the formation of wind. Here's a breakdown of the key factors involved. Pressure gradient. The pressure gradient refers to the change in atmospheric pressure over a given distance. When there is a significant difference in pressure between two areas, air flows from the region of higher pressure to the region of lower pressure. This movement creates wind. The steeper the pressure gradient, the stronger the resulting winds will be. Differential heating. Differential heating of the Earth's surface is a major contributor to pressure variations. Sunlight warms the Earth's surface, but different surfaces, such as land and water, absorb and retain heat at different rates. This creates variations in temperature, which in turn lead to variations in air pressure. For example, land heats up more quickly than water, resulting in lower air pressure over land and higher pressure over adjacent bodies of water. The air moves from the higher pressure over water to the lower pressure over land, generating wind. Coriolis effect. The Coriolis effect is an apparent deflection of wind caused by the rotation of the Earth. As air moves from areas of high pressure to low pressure, it is subject to the Coriolis force, which causes it to deflect to the right in the Northern Hemisphere and to the left in the Southern Hemisphere. The Coriolis effect influences the direction of wind, but does not directly cause it. Friction. Friction with the Earth's surface affects the speed and direction of wind near the surface. Surface features such as rough terrain or the presence of buildings and vegetation can slow down the wind or alter its direction. Winds higher up in the atmosphere are less affected by friction and tend to move more freely. Local and global circulation patterns. Wind patterns are also influenced by various local and global circulation systems. Examples include sea and land breezes, mountain and valley breezes, trade winds, prevailing westerlies, and polar easterlies. These patterns arise due to the combined effects of pressure gradients, differential heating, and the Coriolis effect. In summary, wind is primarily caused by pressure differences in the atmosphere, which result from uneven heating of the Earth's surface. The movement of air from areas of high pressure to low pressure, driven by the desire to equalize these pressure imbalances, generates wind. Factors such as the Coriolis effect, friction, and circulation patterns further influence the speed and direction of wind. Q6176. Winds at 5,000 feet AGL on a particular flight are southwesterly, while most of the surface winds are southerly. This difference in direction is primarily due to A. Local terrain effects on pressure. B. Stronger Coriolis force at the surface. C. Friction between the wind and the surface. The correct answer is C. The difference in wind direction between 5,000 feet AGL, above ground level, and the surface is primarily influenced by the effects of friction between the wind and the surface. This phenomenon is known as surface frictional drag. As air flows over the Earth's surface, it encounters various objects and surface features such as buildings, trees, hills, and other obstacles. These objects create surface roughness that disrupts the smooth flow of air. The air molecules in contact with the surface experience frictional drag, which slows down their movement. Near the surface, the frictional drag effect is more pronounced due to the greater surface roughness and the higher concentration of obstacles. As a result, the wind speed near the surface is reduced compared to higher altitudes where the influence of surface friction is less significant. The frictional drag also causes a change in wind direction. As the wind encounters surface features, it experiences horizontal forces that can deflect its path. The magnitude and direction of these forces depend on the surface roughness and the angle at which the wind approaches the obstacles. These forces can cause the wind to deviate from its original direction, leading to differences in wind direction between different altitudes. At 5,000 feet AGL, the wind is generally less affected by surface friction and encounters fewer obstacles. Consequently, the wind at this altitude tends to have a more consistent direction, often reflecting the larger-scale atmospheric patterns and weather systems. In contrast, the surface winds are influenced by the frictional drag and encounter a greater number of obstacles. This results in a change in wind direction, which can vary from the wind direction at higher altitudes. It's important for pilots and meteorologists to consider these differences in wind direction between altitudes when planning flights or analyzing weather conditions. The variation in wind direction due to surface friction can have implications for aircraft operations, including takeoff and landing procedures, crosswind considerations, and overall flight planning. 6175. The wind flow around a low pressure is A. Cyclonic, B. Adiabatic, C. Anticyclonic. The correct answer is A. The wind flow around a low-pressure system is cyclonic. Cyclonic flow refers to the counterclockwise rotation of wind around a low-pressure center in the Northern Hemisphere. This rotation is a result of the Coriolis effect, which causes moving air to be deflected to the right in the Northern Hemisphere. In cyclonic flow, the wind circulates inward toward the low-pressure center in a counterclockwise direction. This flow pattern is commonly associated with weather systems such as storms, frontal boundaries, and areas of low pressure. Cyclonic flow is often characterized by unsettled weather conditions, including cloudiness, precipitation, and strong winds. On the other hand, anticyclonic flow refers to the clockwise rotation of wind around a high-pressure center in the Northern Hemisphere. Anticyclonic flow is associated with more stable weather conditions, such as clear skies and lighter winds. The difference in wind direction between the surface and 5,000 feet AGL, above ground level, is primarily due to friction between the wind and the surface. As air moves across the Earth's surface, it encounters frictional forces that slow down the wind near the surface. This frictional effect causes the surface winds to have a different direction compared to the winds at higher altitudes. Therefore, the surface winds may have a southerly direction while the winds at 5,000 feet AGL may have a southwesterly direction. This difference in wind direction with height is known as wind shear. 6177. In the Northern Hemisphere, a pilot making a long-distance flight from east to west would most likely find favorable winds associated with high and low-pressure systems by flying to the A. North of a high and a low, B. North of a high and to the south of a low, C. South of a high and to the north of a low. The correct answer is C. High-pressure system. High-pressure systems are associated with descending air masses and generally result in clear skies and more stable atmospheric conditions. In the Northern Hemisphere, the air circulates clockwise around a high-pressure system. As air descends in a high-pressure system, it spreads out and diverges near the surface. This divergence at the surface creates a region of relatively calm winds and light surface winds. However, aloft, the air tends to flow outward from the high-pressure system. By flying to the south of a high-pressure system, a pilot can take advantage of the clockwise circulation and potentially encounter favorable tailwinds. Low-pressure system. Low-pressure systems are associated with ascending air masses and are typically characterized by unsettled weather conditions. In the Northern Hemisphere, the air circulates counterclockwise around a low-pressure system. As air ascends in a low-pressure system, it converges and rises, creating a region of rising motion and potential precipitation. Near the surface, air flows inward toward the low-pressure center, resulting in surface winds that generally rotate counterclockwise around the low. By flying to the north of a low-pressure system, a pilot can take advantage of the counterclockwise circulation and potentially encounter favorable tailwinds. Favorable winds. Flying to the south of a high-pressure system and to the north of a low-pressure system allows a pilot to position the aircraft in a region where the prevailing winds tend to blow from west to east. These westerly winds, commonly known as the prevailing westerlies, are the primary wind belt in the middle latitudes of the Northern Hemisphere. By flying in this zone, a pilot can benefit from the assistance of tailwinds, which can increase ground speed and reduce fuel consumption during an east-to-west flight. In summary, when making a long-distance flight from east to west in the Northern Hemisphere, It is generally favorable to fly to the south of a high-pressure system and to the north of a low-pressure system. This positioning allows a pilot to take advantage of the prevailing westerly winds and potentially encounter favorable tailwinds. 6178. When flying from a high to a low-pressure area in the Northern Hemisphere, the wind direction and velocity will be from the A. Left and increasing. B. Left and decreasing. C. Right and increasing. The correct answer is A. High-pressure area. In the Northern Hemisphere, high-pressure areas are associated with descending air and relatively stable atmospheric conditions. The air in a high-pressure system moves in a clockwise direction around the center. As the air descends, it spreads out and diverges near the surface. This divergence at the surface creates a region of relatively calm winds and light surface winds. The wind circulation aloft is clockwise, which means the wind moves in a clockwise direction around the high-pressure system. Low-pressure area. In the Northern Hemisphere, low-pressure areas are associated with ascending air and unsettled weather conditions. The air in a low-pressure system moves counterclockwise around the center. As the air rises, it converges and ascends, creating a region of rising motion and potential precipitation. Near the surface, air flows inward toward the low-pressure center, resulting in surface winds that rotate counterclockwise around the low. Flying from high to low pressure. When flying from a high-pressure area to a low-pressure area, the pilot will be transitioning from an area of high pressure to an area of lower pressure. The air will tend to flow from the high-pressure area toward the low-pressure area. Due to the Coriolis effect, which is the deflection of moving air caused by the Earth's rotation, the wind direction will appear to be from the left of the pilot's heading in the Northern Hemisphere. Wind speed. As the air moves from a high-pressure area to a low-pressure area, it accelerates due to the pressure gradient force. This acceleration results in an increase in wind speed. Therefore, when flying from a high to a low-pressure area, the wind velocity will be increasing. In summary, when flying from a high to a low-pressure area in the Northern Hemisphere, the wind direction will be from the left of the pilot's heading, and the wind velocity will be increasing. This is due to the clockwise circulation in high-pressure systems and the counterclockwise circulation in low-pressure systems, as well as the pressure gradient force driving air from high to low pressure. Therefore, the correct answer is left and increasing.